So in the good morning students. So in the last class we discussed about the Q learning concept. Now we have taken one simple example in the last class where we have seen that we have a room. Where we have a particular building which is consisting of 5 rooms, and those 5 rooms are available within the building, and the other room was available outside the building. And we were trying to move from one room to another room. So the room which are directly connected to the outside room, which is room number 5, so you are getting the reward 100, otherwise you are getting the reward 0. And the rooms which are not at all having a direct link between each other, so there we kept the value -1. So we prepared this R matrix in the previous class. So this is my reward matrix which we have prepared. Now we are trying to solve this particular example with the help of Q learning, and I told you that we are using a formula. Wait a minute. I'll show you the formula what we are using here. We are using a formula, this formula where I'm using a terminology gamma. So I'm using gamma terminology here. So in this case, we are using a learning parameter. Gamma is nothing but my learning parameter. So we have chosen in this example learning parameter as 0.8, and we are assuming that my agent is initially in the room number 1. So now initially a agent is in a room number 1. So and from room number 1, agents want to move to room number 5. So you can see here, agent can go from room number 1 to room number 3, or agent can go from room number 1 to 5. So from room number 1, you can go to room number 3, or you can go to room number 5. And from room number 5, now you have to calculate maximum Q value for the next state based on all possible action. So I have to see that from room number 5 where I should go so that I will get the maximum rewards. Okay, so my final destination is room number 5, and from room number 5 I should stay in room number 5, or if I have to explore other options also, so that we have to verify here. So this is my formula which I've shown earlier. So I want to calculate Q value here. So Q value I want to calculate between 1 to 5. So I want to calculate Q between 1 to 5, and I'm using for calculating Q value, I'm using the reward matrix. And in the beginning, we are assuming that my Q matrix is 0. Why we kept Q matrix all values 0? Because we are assuming that till now, agent have not learned anything. There is no learning for the agent. So in the beginning, agent don't have any memory. So as soon as agent will start learning, then these values will be filled by the learning of the agent, and we'll try to get the optimal solution so that we will understand that this particular policy is better to maximize the reward. For that reason, we are preparing the Q matrix. So in the beginning, my Q matrix is 0. I hope you understood. Now I want to move from room number 1 to 5. So I want to find the Q value of 1 to 5. You can see here Q value between 1 to 5 is 0. I want to calculate this, the new Q value, if I am taking that particular step. So calculating this, I'm using a reward of between 1 to 5. Reward between 1 to 5 plus 0.8 multiplied by 0.8 is gamma value. And this value we are multiplying with, one second. So this particular value we are multiplying with reward value between 1 to 5 plus gamma value is 0.8 for me. And now if I am at this particular state, if I'm choosing this particular state, so further also I have a possible that I can go to 1, I can go to 4, I have to stay to 5 only. So I have to explore all the possibility. So whatever will give me the maximum value that I'm choosing. So that's why we are writing here max of what? Q value between 5 to 1, Q value between 5 to 4, and Q value between 5 to 5. Okay, and we are calculating here. So what is reward value between 1 to 5? For me, reward value between 1 to 5 is 100. So that's why we kept here value 100 plus my gamma value, which is 0.8. So, and now I'm saying the Q value between 5 to 1. So as we know that this is the beginning stage, all Q values are 0. So definitely 5Q, 5.1 will be 0, 5.4 is also 0, 5.5 is also 0, and the maximum of 0 is always 0. And when we'll solve this particular, we'll get the value 100. So my Q15 is now 100. So this 0 will be replaced by now 100. So this modification we will do in Q matrix. So I hope it is clear to you that how we have done this. Now further, suppose now we are assuming in the next episode we are saying that we start with the randomly, we are starting with the state which is 3. Earlier we started with some other state. Now we are starting that currently we are in the state of 3. Now from 3 I have to go to 5. Okay. Now I can't reach directly to the 5. So I have to choose any path. I can go from 3 to 1, 3 to 2 or 3 to 4. And if I'm choosing 3 to 1, then again there is a possibility that I can go to 3 or I can go to 5. So in that way I have to reach to the final state. So from room 1, I have to calculate maximum Q value between from 3 I reach to 1. Now from 1 I can go to 5 and I can go to 3. So I have to see which path I have to choose to so that I can get the maximum reward or maximum Q value. Okay, so we are choosing from 3 to 1. So I want to find Q value between 3 to 1, which is equal to what? The reward of 3 to 1. So reward of 3 to 1 we are writing. Reward of 3 to 1 is what? For me it is 0. Reward of 3 to 1 is 0. That's why we written 0 plus gamma value multiply by from 1 I can go to 3 and I can go to 5. So from 1 to 3 what is my gamma, what is my Q value? 0. So that's why we kept here 0. And from 1 to 5 what is my Q value? It is 100. That's why we kept here 100. And when we'll solve this one we will get the result which is 80. So now my Q31 is updated by 80. That's why my matrix is having now new value which is 80. So I hope it is clear that how we are finding the Q value for the next episode. Fine. Now we are taking the another episode in that we are saying for the next episode, the next state is 1. Now this one is my current state, suppose. So now this one is the current state. Now we have to return, we have to repeat the same inner loop for the Q learning algorithm because state 1 is not my goal. My goal is what? My goal is to reach to the 5. So if you are currently not in the final state, you have to repeat your method or your process again and again until you are not reached to the room number 5. So now what is the process here? From 1 you can go to room number 5 and from 5 again you have to explore that you can go to 1, you can go to 4 or you can go to again 5. So you have to calculate the Q value between 1 to 5. So we have written here Q value between 1 to 5 and I'm calculating the reward which is reward between 1 to 5. So we have kept reward between 1 to 5 plus my gamma value which is 0.8. Now I have to find the Q value between 5 to 1, 5 to 4 and 5 to 5. So what is my Q value between 5 to 1? If you see the matrix, my Q value between 5 to 1 is 0. Q value between 5 to 4 is again 0 and Q value between 5 to Q value between 5 to 5 is uh, Q value between 5 to 5 is again it should be 100, it should be 100 actually. Q value between 5 to 5 is 100. So it should be 100. Okay, so it is 100. No, sorry, 100 was in the reward, not here. So 100 was in the reward. We are not considering reward. We are considering Q value. So Q value between 5 to 5 is again 0. So we kept here the all values are 0. So maximum of 0 is always what? It is 0 only. So we'll get the value which is 100. So Q value will be updated here. Your 1 to 5 will become 100, but it is already updated in the previous session only. In the previous episode only, we already updated. So that the previous value will remain here. So if you will get more than this, if your rewards are more than 100, then only you are going to update. Otherwise, you are not going to update this because whatever is there in the Q learning metrics, that will be the highest reward by choosing a particular state to the other state. So in that way, you are going to fill your Q learning matrix. So in this way, Q learning works. So I hope it is clear to you that how Q learning works. So now you will understand the algorithm steps. So what we are doing, first of all, we are setting the gamma parameter. We set the gamma parameter in our example, which is 0.8. And the next we are taking Q value, Q matrix, which we are initializing with 0. So your Q value will have Q matrix will have all 0. Now you are selecting a random initial state. You can select any state as a initial state. Okay, and your initial that, or you can say, you can set your current state also as a initial state. So current state will become initial state, and select one among all possible action from the state. So suppose you are at 1, you can have to choose which is what possible action you have to take, so that you can choose your state. So you will select one among all the possible action for the current state. Using those possible action, you will reach to the next state. So if I'm choosing this particular action, maybe I'll reach to state number 4. If I'll choose this, I'll reach to 5, or if I'll choose, I'll reach to 3. So whatever action I'm choosing, accordingly, I will go to the next state. And whenever I'm doing this, I'm trying to get the maximum Q value for the next state based on my action. So whatever action I'm performing, suppose I'm getting here 0, here 0, and I'm getting 100. So definitely I will choose this particular action because I'm getting the maximum reward here if I'm choosing this particular action. So I'll try to get the maximum value for the next state based on the possible actions. And I'm computing Q of state of action using the formula which we have discussed. And we'll repeat the same thing until and unless your current state is not equivalent to the goal state. We are going to repeat the same strategy. In that way, Q learning works. I hope it is clear to you how Q learning works. Thank you.